Event Coordinator, Assistant Professor, Civil Engineering, VNRVJIET onto the dais. May I now welcome Dr. K. Suresh Sir, Event Coordinator, Senior Assistant Professor, Civil Engineering, VNRVJIET onto the dais. I now take great pride in welcoming Dr. B. Channakeshwar Rao Sir, Principal, VNRVJIET onto the dais. With great pleasure, now I welcome our guest of honor, Dr. P. Hari Krishna Sir, Professor, Department of Civil Engineering, NIT Warangal, onto the dais. Now I take great pleasure in welcoming our Chief Guest, P. Suresh Kumar Gupta Sir, Technical Director and Head of TGE, Jacobs Engineering Private Limited, onto the dais. Thank you all. The lighting of the lamp symbolizes the beginning of a day filled with knowledge, innovation, and inspiration. To mark the auspicious beginning of Geoid 2026, I now request our respected dignitaries on the dais to kindly come forward for the lamp lighting ceremony. I request our esteemed alumni, Ms. Prashanti ma'am, to also join them. To invoke the divine blessings for the successful conduct of this event, now I invite Kruti to come forward and to present the prayer song.
शारदे करुणानिधे सकलानवाम्ब सदा जनान् शारदे करुणानिधे सकलानवाम्ब सदा जनान् चारणादिमगीतवैभवपूरिताखिल दीप्तते शारदे करुणानिधे सकलानवाम्ब सदा जनान् चारणादिमगीतवैभवपूरिताखिल दीप्तते शारदे करुणानिधे हस्तसंधृतपुस्तकाक्षपटी सुधा घटमुद्रिके हस्तसंधृतपुस्तकाक्षपटी सुधा घटमुद्रिके कस्तवस्ति वर्णने चतुरो नरखचरोतवा शारदे करुणानिधे सकलानवाम्ब सदा जनान् चारणादिमगीतवैभवपूरिताखिल दीप्तते शारदे
Thank you, Kruti, for the soulful prayer that has set a pleasant tone for today's program. To commence the event, may I now welcome Dr. K. Ramoji Sir, Head of the Department Civil Engineering, VNRVJIET, to deliver his address and brief us about the activities of the Civil Engineering Department. Welcome, sir.
Respected Principal Sir, Dr. Chankeswara Garu, and today's Chief Guest, Sri Suresh Kumar Gupta Garu from Jacobs Company, India Limited. Guest of Honor, Professor Hariprasad Garu, Professor NIT Warangal, Department of Civil Engineering, our coordinators of this workshop, Sangeeta Madam and Dr. Suresh, and Deans, HODs, delegates, and my dear students. It gives me immense pleasure to extend a warm welcome to all of you. A two-day intercollegiate geotechnical symposium organized by Department of Civil Engineering, VNRVJIET, in association with Indian Geotechnical Society, Hyderabad chapter. So first I would like to address about the department. The Department of Civil Engineering was established in 2001, offering one UG program, that is BTech in Civil Engineering, and 3 PG programs, Structural Engineering, Geotechnical Engineering, and Highway Engineering. Our BTech program has been accredited by MBA for 6 years successfully for second time, and our PG program, MTech Structural Engineering, is also accredited by MBA, reflecting our strong commitment and academic excellence and quality education. We have 32 highly qualified faculty on board, out of which 20 faculty are having PhD, mentoring students in cutting-edge research and innovative projects. Our faculty members also guide PhD scholars, contributing to significant advancements in the field. Our laboratories are equipped with state-of-art facilities like from drones and GPS systems for advanced surveying to simulation softwares like ETABS, ANSYS, MATLAB, BIM, VISIM, Plaxis, and GeoStudios for complex analysis. We also have advanced testing equipment like triaxial shear test, SPT test setup in geotechnical engineering, rheometer, wheel rating machine, 100 tons loading frame, carbonation chamber, universal testing machine, and atomic absorption spectrophotometer, providing our students hands-on experience aligned with our real-world engineering practice. Our MOIs with industry partners enable internships, workshops, and knowledge-sharing sessions, bridging the gap between academia and industry. Research remains the cornerstone of our department, with a cumulative funding of over 1.24 crores from AICTE, DST, and UGC bodies. We continue to pursue innovation in smart infrastructure, sustainable construction, and geotechnical engineering. Our strong research ecosystem, expert faculty, and modern infrastructure create an environment that encourages interdisciplinary research and a robust industry academic connect. The theme of this workshop, that is geotechnical opportunities in infrastructure development, is both timely and significant. Geotechnical engineering opportunities in India are driven by infrastructure growth in metro rail, highways, and high-rise construction. Top roles include design engineers, site investigators, and project managers, with high demand in Hyderabad, Mumbai, Chennai, Delhi, Kolkata, and Pune, for which skills needed are Plaxis software, AutoCAD, soil mechanics, as well as foundation design. In fact, geotechnical engineers have better prospects such as infrastructure projects like major demand in metro rail projects, NHI, and tunneling projects. And consulting design firms, companies like WSP, Covi India, Atkins Realis, Jacobs, Sistra, and Maynard Group for roles ranging from site investigation to design analysis. And if you look at the construction and EPC companies like L&T, DVM Geotechnics, and Vyant Solutions offer roles in site execution and pile foundations. So I take this opportunity to express my sincere gratitude to our management and principals for their constant support and encouragement in all our academic and research initiative. initiatives. My heartfelt thanks to our distinguished chief guest, Suresh Kumar Gupta Garu, and guest of honor Professor Harikrishna Garu for accepting our invitation and gracing this occasion with their presence. A special word of appreciation to organizing committee, faculty members, and student volunteers for their dedicated efforts in making this event possible. I am confident that the expert lectures, poster presentations, and technical quiz deliberations and discussions during this workshop will lead to meaningful collaborations and innovative ideas. So today we have our special guest, Prasanthi Madam. She is from Jacobs India Limited, and he graduated from Geotechnical Engineering batch 2012 to 2014. She readily accepted to give a lecture to all our civil engineering students as well as geotechnical engineering students. Thank you. With this closing remarks, thank you all. Thank you once again.
Thank you, sir, for your inspiring words and for sharing the vision of the department. It is now time to invite Dr. S. Sangeeta Ma'am, Event Coordinator, to formally extend our heartfelt welcome and to share the proceedings of the event. Welcome, ma'am.
Honorable dignitaries, respected professors, and my dear students. Good morning to one and all present here. So, we are already loaded with labs, external exams, internal exams, projects, etc. Right? So, amidst of all these hazards, again this symposium. So, why Geoid 2026? You know what? Professor Elon Musk, in his biography, has mentioned the best minds of my generation are thinking about how to make people to click on advertisements. Very true, right? We all are writing quotes to make people to buy products online. Of course, that is also important in this fast-moving world. But still, Geoid 2026 has the mission to enrich and nurture the knowledge of my budding civil engineers in the geotechnical engineering domain. You know what? Mother Earth is neither a sphere nor an ellipsoid. It has a unique shape and is named as geoid. Similar to its shape, its behavior is also unique. Man, with all his technological capabilities, is always attempting to understand its behavior. Philosophically, I can say you something, everything starting from this chair, table, plastic, coal, oil, everything originates from soil. Our each and every infrastructure facilities like dams, bridges, tunnels, roads and whatnot have its support from either soil or rock. Let us explore this humble ground in this Geoid 2026 that bears you and I. Fine. And to start with this symposium, in the morning we have expert lecture session from Sri Suresh Kumar Gupta from Jacobs, followed by Professor Harikrishna sir from NIT Warangal, my guru. And on the afternoon session, we have technical quiz, which is there to sharpen the brains of young engineers in soil mechanics and foundation engineering. And we have parallel session B plan that showcases the civil engineering startup ideas of young civil engineers. And on day 2, we have GeoStudio training workshop as well. And followed by, we have innovative poster presentations session to showcase ideas of our young engineers. And followed by, we have another event that tests your compaction skills and knowledge on IS 2720 Indian standards that deals with soil testing facilities. Finally, there is one concept in soil mechanics, you all remember I guess, pre-consolidation pressure, which states that soil, especially clay, has memory, right? To make your Geoid 2026 experience memorable, we have an informal event also, which is pottery, right? In a lighter tone, I can say, go with a clear mind and dirty hands. So hope you all have a better learning in Geoid 2026 at VNRVJIET. Thank you all.
Thank you, ma'am, for your inspiring words and for warmly welcoming everyone to Geoid 2026. We are privileged to have with us our principal, Dr. V. Channakeshwara Rao, sir, a visionary academic leader. May I now request you, sir, to address the gathering.
Good morning to all of you. Namaskar. Swagatam, Suswagatam to all the experts on the dais and off the dais, my dear students. You're all, I think, smiling faces. So you all belongs to Royal Civil. I think, please all of you, give a big hand to all of you. So respected today's chief guest, Suresh Kumar Gupta Garu, Technical Director and Head of EGE, Geoid Engineering Private Limited, and our beloved Professor P. Harikrishna Garu, Professor Department of Civil Engineering, National Institute of Technology, Warangal, and Ramoji Garu, and Deans, and my dear colleagues on the dais and off the dais, ladies and gentlemen. First of all, I would like to congratulate the department for organizing two-day Geotechnical Symposium on Geotechnical Opportunities in Infrastructure Development. So as you're all aware that today I think everybody is migrating to computer science and allied subjects, but in spite of that I think there is a great demand for civil engineers. So please all of you uphold your values and the quality and affordable houses that you are going to develop in the area of I think civil engineering. So soil mechanics is one of the important subject. I think unless you have a strong foundation, you cannot build bridges or high-rise structures like 50 stores structures we are developing nowadays in Hyderabad. So I think there are so many technologies that are available. So please try to acquire the knowledge that is required in this particular soil mechanics, and rock science also, that is very important, and the water. So these are the three areas I think which are very important. Unless you acquire the knowledge in these three areas, I think you cannot build structures or bridges or whatever the things that you want to build. So I would like to congratulate Sangeeta Madam and Suresh Garu and for organizing this two-day event at VNRVJIET. So I think this type of event definitely will improve your knowledge in this particular domain. So I would like to thank all the experts who have come forward to deliver the lectures. Our own alumnus, I think she has come forward to deliver the lecture on this particular topic. So in this connection, I request all of you please try to attend all the sessions. I think the sessions that I think they are going to conduct expert lectures. So we have invited experts from both academia and as well as industry. So definitely you are going to interact with the experts and acquire the knowledge. That is very important. Poster presentation, I think with the help of the poster presentation, definitely you can acquire the knowledge and as well as use the new technologies that are coming up in this particular area and present your ideas in front of the judges. Quizzes, you have preliminary and finals, and Geo Studio workshop is going to be conducted, and all these are all I think very important. Please all of you attend all the sessions and acquire the knowledge that is required by the industry, civil engineering industry. So today I think it is very difficult to acquire the knowledge in this particular field because everybody is migrating to artificial intelligence, IoT, even though you belongs to civil, but using all these technologies, your job is made easy. So that is it. That's why please try to learn new technologies which are very important at this particular area, and try to use the new technologies like emerging technologies in your core domain. So that way you are going to enrich your knowledge. I hope you are going to enjoy these 2 days and you'll have a great learning at VNRVJIET. I wish you all good luck. Thank you once again.
Thank you, sir, for your motivating message and the continued support to our civil engineering department. Before inviting our guest of honor onto the dais, I invite Ms. Likita of 3rd year BTech CE to come forward and to introduce our guest of honor, Dr. Harikrishna sir, onto this.
Good morning, everyone. It is a privilege to introduce our guest of honor, Dr. Padavala Harikrishna sir, a distinguished scholar in geotechnical engineering with more than 3 decades of teaching and research experience. Professor Harikrishna sir has made significant contributions to civil engineering through over 145 research publications, a textbook, and 3 patents, along with impactful research on expansive soils, geothermal piles, ground improvement, and sustainable infrastructure. His work has been widely recognized with several prestigious honors. He has received multiple Best Paper Awards from Indian Geotechnical Society, the Bharat Jyoti Award, the Best Teacher Award from NIT Warangal from 2022 to 2023, and international recognition such as Leadership Excellence Award 2024, Intellectual Achievers of the World Award 2025, and Mother Teresa Global Award 2026. In addition to these achievements, he actively contributes to the global research community as a reviewer for international journals and has presented his work in countries including USA, Singapore, London, UAE, and Japan. Through his outstanding research, teaching excellence, and numerous recognitions, Professor Harikrishna Sir continues to inspire the engineering community and contribute to the advancement of sustainable civil engineering. Thank you.
Thank you, Likita. Now I request Dr. Harikrishna Sir to address the gathering.
The dignitaries on the dais, faculty members of VJIET, and the young student friends. A very good morning to all. It's a really great privilege and honor and happy to be here in this prestigious institute, VNRVJIET, as one of the technical person to share some of my ideas. Of course, my talk is after the tea break. Just like recently we had 2020 World Cup, T20. First session is good, second session is interesting, and it will be very happy, okay? So wherein we will be having some of the research findings, which are one and only thing happened in NIT Warangal, along with some details of our department's endeavor to restore the Kakatiya monuments, which were constructed by the great Kakatiyas 1,000 years back. Friends, frankly speaking, this type of opportunity, and as the name itself is saying, there is a lot of opportunity to prove ourselves as a good civil engineers. Civil engineering is one of the main branches which has every day its opportunities. It's only our turn to grab the opportunities. And I really congratulate the administration of this institute to take up this initiative in going for this symposium. And they have taken balancing of industry and academia, because these things is very important. We are developing, giving the students to industry to meet their requirements. I really appreciate and encourage and thank the administration for giving me the opportunities. Hopefully we'll share good amount of knowledge. Thank you one and all. Thank you.
Thank you, sir, for your motivating words. Now I invite Ms. Sucharita Reddy from 3rd year BTech Civil Engineering to come forward and to introduce our chief guest, Mr. P. Suresh Gupta, sir.
Good morning, everyone. It is my great pleasure to introduce our chief guest, Mr. P. Suresh Kumar Gupta, sir, Technical Director, Tunnel and Ground Engineering at Jacobs, India. Mr. Gupta, sir, is a chartered engineer with the Institution of Civil Engineers, UK, and a certified professional engineer with Engineers Australia. With over 21 years of experience in geotechnical engineering and major infrastructure development. In his current role, he leads technical delivery and engineering quality for complex tunneling and ground engineering projects while guiding multidisciplinary engineering teams. During his career, he has worked on several large-scale international infrastructure projects, which includes developments related to Bangalore, Noida, and Guwahati international airports, the California High-Speed Rail Project, the Route 2020 Dubai Metro, and the NEOM Megacity project in Saudi Arabia. His expertise spans foundation engineering, tunneling systems, slope stability, ground improvement, and also advanced geotechnical design for complex infrastructure systems. His professional excellence has been recognized with several awards, including the Technical Excellence Awards from Jacobs, Outstanding Performance Awards in 2021 and 2024, and recognition as a finalist for the EVE Award at Petrofac. With his extensive global project experience and leadership in geotechnical engineering, Mr. Gupta sir continues to contribute significantly to the development of innovative and sustainable infrastructure developments. Thank you.
Thank you, Sucharita. Now I request Mr. P. Suresh Gupta, sir, to address the gathering. Welcome, sir.
Good morning, all. Good morning to all distinguished guests of the dais, and esteemed speakers, and my dear students, future innovators, and probably colleagues and clients. So it's indeed actually a great pleasure for me, and it's an honor to be invited as a chief guest along with the dignitaries, Professor P. Harikrishna Garu. And this symposium is about the geotechnical opportunities in infrastructure development. So I extend first of all heartfelt gratitude towards the organizers for inviting me and to be part of this young, dynamic, talented people to share my thoughts, my past experience, and some of the knowledge. So gatherings like this, it's not about just like a presentations, I feel. It's not about the discussions, but it is all about collecting the ideas. So it's all about like ideas and the people who think or who are willing to think differently to come forward, challenge the conventions like whatever is accepted, and for the better future, for the better generations. So majority of the people ask me like what is the best branch in engineering. So probably I would like to hear from you also what is the best branch? Civil. Okay. But my answer was changing honestly from the day to day, year to year. Maybe when I was a student it is different opinion, but later, so now I realized what is the importance. After maybe 15 years of experience, now I'm hanging around 20 years. It all depends on the passion, the one you are really interested, and it is coupled with the passion to keep learning. So whenever you feel that you have a passion, so you already decided to be a civil engineer. If you don't have passion, then better to build or cultivate that passion. Otherwise, you can't sustain in the long run. So I saw many friends like the guests how they express, right? Many people are moving from civil engineering, but from the day one, like I did like my diploma in civil engineering from 1996 to I used to hear, hey, are you a civil engineer? Are you a civil engineer? But I just like kept quiet and continued my studies. But after completing my MTech, it was different. So you need to just like patience, perseverance. That is really important in the current day. So people may speak a lot about your branch or your profession or your interest, but keep aside. Maybe you can think, step back. Hey, what I'm doing is right or not. So if you feel that yes, I am doing right, better to continue. So, and you are living in a time of like transition, time transition, right, from academics to industry. So majority of the times, like industry is not keen to know what you know. So industry is like looking after what you can solve and how. So these are the two important. And the golden era, like my time, it was different. Maybe the engineering degree might have secured a job or career. Those days are gone. So your learning is different. So now this degree is just a foundation. So your learning begins after your degree. So please remember, so your learning starts only after your degree. And like one of the student said about like geotechnical engineering is backbone. Yes, it is a backbone, but it is a hidden backbone. So many people haven't seen, it is invisible. We can't see it majority of times, but it is indispensable. So without geotechnical engineering, there won't be any other structure like infrastructure. Already speakers said, from metros to airports, dams, everywhere. If you name it, that's we are here. And if you look at the growth or importance of the geotechnical engineering, right now the budget is almost 60 billion USD globally, 60 billion USD, and it is going to be 120 billion USD by 2035. So you imagine the growth trajectory on the geotechnical engineering and the opportunities. so awaiting for you in this field. And as a future engineers, maybe I encourage to embrace uh, I encourage you to embrace innovation and uphold ethics, like one of the professors said about the ethics, and never stop learning. So if you stop learning, then that is the end for your career. So even for life also, it teaches a lot. Maybe you need to just remember again, so the days when you started crawling, or maybe started speaking a few words, now where you are. So you already are successful in terms of academics. But now onwards, you need to think in a different way. You need to perceive, understand the perspectives of different people, different opinions. It's not about arguing, or rather understanding and stepping into the other's shoes. Let's work not only about the building infrastructure, the major thing is building the trust. And the structures where you are going to work has to be very safe enough and sustainable, so that future generations also thrive. How you are enjoying right now, so we need to work for the future generations as well. So thank you, and I wish this symposium great success and may inspire each one of you to dig deeper, so that literally and figuratively you can add value, and maybe it is going to lay a foundation for your brighter future. Thank you.
Thank you, sir, for your inspiring words and for motivating all of us to be continuous learners. As we come to the conclusion of the inaugural session, I now invite Dr. K. Suresh, sir, Event Coordinator, to deliver the voters' thanks. Welcome, sir.
Good morning to one and all. It is my great privilege to propose the vote of thanks on this auspicious occasion of inaugural session Geoid 2026, Geotechnical Opportunities in Infrastructure Development, organized by the Department of Civil Engineering, VNRVJIET Institute of Engineering and Technology. First and foremost, I would like to express my heartfelt gratitude to our esteemed chief guest, Sri P. Suresh Kumar Gupta Garu, Technical Director, Jacobs Engineering India Private Limited, Hyderabad, for graciously accepting our invitation and for delivering an insightful inaugural address. Your valuable thoughts, rich professional experience, and inspiring words have truly motivated our students and faculty members. Thank you, sir. I would like to extend our sincere thanks to our guest of honor, Professor P. Harikrishna Garu, Professor, Department of Civil Engineering, National Institute of Technology, Warangal, for sparing your valuable time to be with us today. Your presence and encouraging words have greatly enriched this event. Thank you, sir. My heartfelt gratitude goes to our respected principal, Dr. Channakeshwarao Garu, whose constant encouragement, vision, and support have always been the driving force behind the organization such meaningful academic events in our institution. I would also like to sincerely thank our head of the Department of Civil Engineering, Dr. Ramoji Garu, for his continuous guidance, encouragement, and leadership in making this symposium possible. A special word of appreciation goes to Coordinator of Geoid 2026, Dr. Sangeeta Madam, whose dedicated efforts, meticulous planning, and commitment have played a crucial role in organizing this event successfully. I would like to thank all the HODs and head of the departments, deans, for joining the inaugural session. I would also like to acknowledge the sincere efforts of all the faculty members, organizing committee members, and volunteers whose hard work, coordination, and enthusiasm have made this event a grand success. My sincere thanks to all the participants and students from various engineering colleges who have joined us today. Your enthusiastic participation truly adds value and meaning to this symposium. Finally, I thank each and every person who has directly or indirectly contributed to the successful conduct of this inaugural session. Once again, thank you all for your presence, support, and encouragement. I wish everyone a very fruitful and enriching Geoid 2026, a geotechnical symposium. Thank you.
Thank you, sir, for your words of gratitude. Now, as a token of our gratitude, I request Dr. V. Channakeshwar Rao, sir, our principal, to kindly come forward and to present the memento to Mr. P. Suresh Kumar Gupta, sir. As a token of our appreciation, I now request Dr. K. Ramuji, sir, to kindly come forward and present the memento to Dr. Hari Krishna, sir. Thank you all. As a token of our appreciation, I now request Dr. S. Sangeeta ma'am to kindly come forward and to present the memento to Ms. Prashanti ma'am. Thank you everyone present here. That concludes the inaugural session of Geoid 2026.
So before start the session, I would like to introduce our renowned professor. As you know that Sar got retired in 2016. Sar used to teach data materials, structure analysis. Okay, he's just like junior Timoshenko in our institute. So it is very fortunate to have such great personality. Okay, definitely Sir is going to deliver one small lecture. Okay. Yeah, future days. Okay. So thank you all of you. Thank you, sir. Thank you for coming over here. Thank you.
Hello. Yeah.
We will now start the expert lecture sessions where our distinguished speakers will share their insights on the latest developments in the geotechnical engineering and infrastructure. Now I request Mr. P. Suresh Kumar Gupta sir along with our esteemed alumni Ms. Prashanti ma'am to kindly address the gathering and to deliver the expert lecture. Welcome sir.
Hello. Yeah, thank you so much. Yeah. Okay. So for spending time, first of all, we should know like what you are going to gain because of the time you are going to spend here. So that's the reason I just listed out like what is the outcome of attending this session. So it starts from career prospects and what kind of mindset is suitable. So majority of the people are just running behind the branches where you will get a job. That is our first motive. Even myself, when I was a student, I used to run behind. I used to change. Even now, this is also happening. I thought of just sharing like what kind of mindset is suitable for individual and different job opportunities. You can get it like from now through the chat GPT or artificial intelligence, but still I just like summarize. And what is geotechnical engineering? Already you are aware of it because you are already studying. And importance and roles of geotechnical engineers in day-to-day life in industries and few case studies. So I took the help of Prashanti. So she summarized all the slide deck and she would like to share her experience as well. So and finally, importance of sustainability. Many people are talking about like it's a buzzword. No, it is not the case. Those golden days are gone. So we need to think about the sustainable world. That's the reason, just like few information, it's a very vast subject at the end of this presentation. This is the outline. First, I would like to introduce about the Jacobs, who we are, what we are going to do, and then civil engineering career opportunities, overview of geotechnical engineering, a typical role of geotechnical engineering, case studies, sustainability. And if you have any questions, because this auditorium is simple, so probably you can raise hand at any time, need not to wait till end of this session. So if at all I am going to take few more minutes, please apology. And this is about the Jacobs as a glance. So it started from 1947 and we have almost 400 offices across the globe, 40 countries we are operating and employs 45,000 employees across the globe. And if you look at like India, so we are already 4,000 plus and we have like offices in Middle East, America, Asia Pacific. And the revenue is very huge. And if you look at maybe in our rankings, you can easily search where we are starting. And already esteemed speakers said about what are the prospects and job opportunities. So we are ranked number 1 or either ranked number 2 or 3. So that is the I'm proud to say about Jacobs. And in the top 100 pure consultancies, we are standing as number 1. And this is about the office spread, like we have 7 offices across India. It all depends on the talent and where they are interested. So it's people can move within the offices as well. Okay, this is about like opportunities where you can find. There are like many specializations. As HOD said, like we have like in VNRVJIET is having the structural, geotechnical and transportation or highways, you can name it. So these are the 3 specializations. Apart from that, many multiple specializations, wastewater treatment, estimation, costing, contracts, then construction management. This is though it is important, but like in the last 15 to 20 years, the importance has been rising like anything. And GIS, remote sensing still, and marine and ocean engineering. So if you look at the structures again, there is an option. You can choose like concrete or steel or bamboo structures. So that is a specialization. Though it is in good olden days, people used to build the structures with the bamboos. With the advent of new materials, then we moved to the concrete and steel, but still again going back to the bamboo structures in terms of like sustainable development. And geotechnical, there are many specializations within the geotechnical. There is a rock mechanics, there is a tunneling, and underground structures. Then transportation, like intelligent transportation system, transportation planning, highway engineering, pavement engineering, like a doctor, software MBBS, then MD, MS. In the similar way, now there are like plenty of specializations. So wastewater drainage, wastewater treatment, surveying contracts. So there are like opportunities for you, but it all depends on the individual where you are interested. Don't run behind like lucrative jobs, but as long as you are confident and you are interested, better to adhere to that subject. So even I used to run behind structures. I tried for all IITs, probably three, four IITs, but the minute when I got the from IIT Delhi, like geotechnical, then my professor said, no, better stay back. Need not to run again, need not to look for other IIT. Because that's where he knows very well about what I am. So that's the reason I stood, and I am the only person who are continuing in the geotechnical field among 10 people. So now after 10, 15 years, probably in the first few years it is a different for everybody. We are like living in a comparison world. So we always compare with others to check the happiness or to check the success. Please leave aside, like compare yourself where you started, where you are right now. So that gives like immense pleasure and satisfaction. So you always focus on what you want, where you would like to go. So in that sense, like I always prefer maybe like my subject like geotechnical, so I was fond of foundation and soil mechanics. That's the reason I am continuing in this field. And when it comes to the opportunities, you might have already know about, right? Government sectors like UPS is the central, then state government, railways, there are opportunities. And only one engineering that is still continuing in terms of great job, I would say, like UPSC, so that is the civil engineering, apart from mechanical and electrical. And there are like public sector companies like Maharatna, Miniratna, Navaratna, like NTPC, ONGC, Oil India. So there are plenty of opportunities. Now they are like taking the intake based on the gate score itself, apart from exams. And the private sector, it was a boom. Like maybe when I completed my MTech in 2006. So that's where like the golden period started for civil engineers. To be frank, to be honest. So before that year, people used to struggle like in Delhi, but from 2006, like we are almost everybody got placed. So private sector, infrastructure, there are like again, there are different domains. So where you would like to choose, it all depends on you, and you need to be prepared. So for your career, future career. So infrastructure, it's ever ending. So you can live or you can complete your entire career, but still you have an opportunity in the infrastructure always. So oil and gas, it is again depends on the market and demand, depends on the renewable energies and budget. So there are like opportunities like steel structures, concrete and bamboo structures. Geotechnical is across all the sectors. And transmission lines, steel and foundation, power, thermal, hydropower, nuclear, renewable energy, ocean engineering and marine engineering. So these are the various opportunities you can explore and you can find the right job. But by third year or sixth or seventh semester, you should know where you are heading. Otherwise, it is really a challenging world and it is difficult to get a job or get placed in your passionate career. And on-campus placements and off-campus placements, like Jacobs or other companies, they are encouraging the students to be part, like a summer intern, winter intern. So I know about like VNRVJIET not because of the college promotions, but it is because of the students, alumni. So when I had a conversation 8 years back with the student, he said he is from VNR. That's where the trust developed. Hey, this college is really renowned because the skill set what he is having is fabulous. So then later after 3 years, maybe Prashanti joined. Then I was really surprised and I wanted to visit the college maybe last 3-4 years, but I haven't. So the minute when I got a call through my ex-colleague, so I went to share a lecture. That's where I am standing here. So it's all about you and your career, and you are going to build the credibility to the college. So decide yourself where you would like to go and start thinking towards the goals, your goals. Yeah, key attributes. Majority of the times, nobody will share what a design consultant. It's not about the subject. I'm talking about your interest and personality. So many people will just go follow maybe others because they are doing it. But after a few years, you will realize and you will regret why I had chosen this path. By that time, you might have already got the experience of 10 years or 5 years, but it is difficult to go back. That's the reason I just shared few thoughts about the attributes. So if you would like to pursue your career in design and consultancy, you should ready to learn continually. The learning, as I said, it is not okay, maybe after your degree you can stop. No, that is not the case. Here, the learning should be very on day-to-day basis. So one should have that appetite to learn continually. And new softwares, new codes, how software industry, how they are changing. Maybe they are changing after every year or 6 months. But here it takes time, 3 years, 5 years. So it doesn't matter how many years of experience, but you need to ready to learn new softwares, new versions, and interested to work within the office environment. Only the opportunity for geotechnical engineers is they can go to the site and they can feel what they are designing. But the rest of the branches, it's very rarely they get an opportunity to visit the sites. That is a major difference. And good communication skills. And site engineer and construction supervisor, you name it maybe. But these people has to ready to face the challenges because it is a construction. Design has been done based on some assumptions or based on hypothetical, need not be hypothetical, but it is bit away from the reality. So the person who love to face the challenges, it is better they need to go to the site engineer and construction career. And understanding of the design, it is not about okay, I'm a site engineer, I need not to know about the design. No, it is not the case. You should know about the basics of design and consequence of each stage. This is really very important. Majority of the failures are happening because the lack of understanding what is going to happen after this. So especially in geotechnical engineering, you have to follow the construction sequence because that is based on design was done based on some certain consequences steps. So one should understand which is first, which is later, and if I do differently, what happens. And people management skills, it is important because one should deal with the different people, different age group, different thought processes and perspectives because the person is going to deal with the different kind of people. And project managers. So once you have good knowledge either in design and site engineers, they can go for the project management and design managers. So it's all about need not to be in depth knowledge for all the specializations, but one should have the good knowledge and depth in one specialization and decent knowledge. Anyway, everybody is their undergraduation in civil engineering, but that doesn't mean that you have broad idea. Over 10 to 15 years, you might have forgotten many things. So you need to know, okay, what others specializations, what is the impact, and good understanding of contracts. So legality. So I don't know exactly VNRVJIET whether they have curriculum, some contracts, what kind of contracts and legality. It is missing the link. So when I studied, but now I hope maybe the curriculum is developed and has an options so to select to know about the contracts and legal issues, HSE, labor laws. That's very important. Again, good communication skills and fair knowledge of impact on each discipline decisions on overall project. Here it is different. Here it is in a broader way. This project manager, the consequences. So I'm just like highlighted good communication skills. So many people think or maybe they thought that good communication skills is about the vocabulary and how they are speaking. No, that is not the good communication skills. You might have no right. While we are communicating, the receiver should understand very well and they should respond as expected. Otherwise, there is no point how good you are in English or native languages. There is no meaning for good communication skills. So one should understand how to communicate and how to get it done. That is important. And I just would like to share the budget, how much it is spent. So people are thinking about the IT or maybe welfare, but if you see like how much budget, it is in the 1,000 crores INR. So for infrastructure and defense, it's 11 lakhs crores for the last year. This is 24-25. And if you look at the 26, it is almost 12 lakh crores. That much money is spending on the infrastructure. So where you look at the semiconductors, electronics, we might have seen like many pictures on the news recently, 6 months before. It is about the 76,000 crores. So you just compare the budget allocations. It's not about the salaries, but how much budget we are spending. So in that way, there is a huge scope for the right civil engineers. I'm talking about the right civil engineers. So overview of geotechnical engineer, already like ma'am said about what is the geotechnical engineering and soil mechanics are already explained. So maybe I'm just going to touch up again. So why it is important, where are these skills are utilized? So you might have having some questions, right? So how many MTech students here? Geotechnical MTech? Okay, so all are civil engineering, either third year or fourth year students, right? So maybe it is relevant then. So soil mechanics, it's a definition. It's basically like applying the principles of engineering mechanics on the soils to predict the behavior of soil. But geotechnical engineering is the broad. You might have already studied the definitions. What is the difference between soil mechanics, geotechnical engineering? So it is going to be covered again apart from soil, but rocks as well as the underground water. This is really important. So this changes, especially for the clay soil or sandy clays, the entire behavior will change. And the geotechnical engineering, so their role will involve in all the stages of projects, like it starts from the investigation, understanding the ground conditions, properties. Do you know how much we are going to take the samples? Not even 0.1% of the ground. And we can't say that, okay, let it go for 10%, 15%. So that is not the norm. So we need to understand, it all depends on how good you are conducting like investigations and what kind of sampling methods and equipments and the crew knowledge, that all matters. Then understanding the earth materials, whether reusing the same material, site-owned material or bringing from outside. Then the design parameters, assessing ground conditions, settlements, performance, and after construction. So it has to be dealt with that throughout the life. So that is the role of geotechnical engineers. And ma'am already said about like why it is important, because it's a mother nature and you can't predict like other materials like soil, concrete, steel or any other man-made materials. And it is very sensitive to the strains. That is also very important, and it is very sensitive to the fluctuation of water tables and the construction sequences. So that's where the geotechnical engineering is very important. So it changes from place to place, and it is not like a fixed parameters for soil. It all depends on the time, loading, past history and the environment and the construction sequence and what kind of equipments you are mobilizing on the ground. It all. And like water, as I said, it is a really key and very important to deal with. Otherwise, it will be like catastrophic failures. And what is the role of geotechnical? I just listed out like it starts from the preparation of specifications. What is meant by specification? Maybe you may are wondering. So it's all about like what you want from the ground. So you are going to list out, hey, you need to do this. And this is the method, like as ma'am said, like IS2720 at the same time. So if at all you are working on the different projects, there is a country codes. So you need to mention all the codes as per the legality, as per the codes. You need to comply with the codes as well. Otherwise, you will be end up in legality issues. So and preparation of layout in the sense of, hey, this is my project, this is my college, so I would like to build a building of G+10 for a hostel. Okay, how many this layout you need to mention, what kind of test, field test, then maybe after collecting lab test that is covering in the BOQ and supervision. So somebody has to. Then review of factual reports, GI, and even there is a like a layer supervision, GIR, then design of foundation system. Initially, we will go with the shallow and deep foundation. I will cover in the coming slides. And earthworks, this is a pretty important, and piling and method statements, how the contractor has to perform at site. That is called method statements. And QAQC, then well foundations. Still, we are using the well foundations, especially for the bridges across any rivers like Ganges. It's all sediment. More than 80-90 meters, you don't find any rock, even in the Brahmaputra river because of the scourings and the loads. Still, the well foundations, people call it as Kaizen, but still it is prevailing in India. Numerical analysis, because with the advent of computers and advanced technologies, we are really equipped, and one should always open to learn. And pile load test, ground improvement is the one I missed, but this is also very important because we can't go for pile foundations, which is very costly and it is not sustainable in terms of. Then load test, you need to visit, the guy has to visit, and enabling works, temporary and permanent. Why it is important? Because majority of the failures are happened during the construction time or just before, like into the operation, because nobody might have not addressed it well with the water, with the slope stability, all those issues. So enabling works are very important, like sheet pile diaphragm walls, tunnels, and database management. This is again very important because you can't go each and every time to conduct the boreholes or to draw the parameters. Maybe hundreds of boreholes, hundreds of CPT tests already conducted, thousands sometimes. If the project is very vast, then it is really challenging. That's the reason like Geoid or Holdbase or the softwares, we can easily retrieve the data. And these are the sectors. So already some of the speakers informed about geotechnical is very important, and you can find across any sector. So rail, road, bridges, metros, advanced facilities like buildings or factory buildings, then oil and gas, onshore, offshore, and conventional buildings, whether it is for college, hostels, or regular office buildings, residential, all buildings. Then aviation sector, it's a big boom. So now it is privatized. So you might have heard the news. So students should follow the news. Actually, this is very important, at least headlines. Otherwise, you will end up somewhere else. So you need to know like where the budget is spending. So what are the major companies are investing, why? So you can see like Adani invested almost on 8 airports, privatization. So apart from that, like BIAL, Bangalore, GMR, Hyderabad, so almost 10 to 12 airports right now, they are under the private. So it's on lease, it's not like completely shifted. At the same time, ports, that is also important. Defense sector, huge investment, you might have seen right on the papers nowadays about the wars. So defense, the budget is huge. You might have seen the defense is the second budget we are allocating from the Indian government. And here geotechnical plays very pivotal role, and marine, renewable energies. So shallow foundation, you already know about like what is shallow foundation, like simple pad footings at a depth of near depth 1.5 to 2 meters, 3 meters, it all depends on the bed. And the deep foundation, again, like piles, caissons, well foundations, which are very deep enough. And these are the few pictures. I thought of maybe sharing the few pictures so you will understand. And slope stability and stabilization. So these are the protection measures. You might have seen recent like failures are happening mostly landslides in Kerala or in the north side. So this protection measures, and you might have seen even in like Yadagiri Gutta, this very huge MSC wall. So these are all like protection measures. And retaining structures, different kind of retaining structures, gravity wall, sheet pile wall, diaphragm wall, shoulder pile wall. It all depends on the height and depends on the type of soil and the purpose, why it is meant for, and how much deformations are allowed for you, and the budget finally, and time. So ground improvement techniques. So there are plenty of ground improvement techniques, and we have like purpose for each and every technique. It is not about okay, let's go for ground improvement technique. As I said earlier, the advancement of materials. So one should be always a continuous learner. So like these techniques. So when I used to study tech program, probably I know only one or two. So now you can find multiple type of ground improvements. It all depends on the advancement in the equipments and greater understanding of the ground conditions and research. Like so, underground construction. So this is also very important tunnels. So if you see from the even within Indian context, in the north side there are many tunnels. Almost 50% of tunnels, like what we are building in India, is located in the north or northeast. It is a strategical importance as well, and for the daily commuting as well. Tunnels are very critical. Even if there is any small change or small understanding, it is going to cost hundreds of crores, and the time may be vary from 6 months to years. Metro stations, you might have seen already in Hyderabad. Basements, 3 basements, 4 basements, and near to the ponds, near to the lakes. So basements, it's not about just like excavating, but it is again challenging to deal with the water permeability and mines. And dam construction. So this is very important and very critical and complex. So if you look at like the developed countries, US, Canada, so their dams might be like more than old of like 100 years. So now building a dam, even within India, if you look at maybe 60 years, 70 years, and you might have heard about like Polavaram, how much we are struggling to build one. But now why dams are important? Because we can't build these dams within a time span of not even 10 years. The entire life of entire career of a person will consume. So understanding of the materials and the water, how it is going to percolate, that is and piping actions. This is really important, and how to release the water pressure on the downstream side. That is also important. And monitoring, yeah, this is the area. Like maybe in India, we never spend that much of attention and time and money. But whereas in the outside or developed countries, it's a mandate for them to have extensive monitoring. Maybe we are also doing monitoring, but that is very limited. So as long as you have a good monitoring data, then you can't go back and check whether your design parameters are right or wrong. And at the same time, the performance, whatever you envisage during design, whether is it performing rightly as per your thought process or your estimation or expectations. So monitoring is very important, and you need to change the designs. It's sometimes it is a live design. Depends on your monitoring data, you need to adapt to the new solutions. Reinforced earth walls, you might have seen many reinforced earth walls, and at the same time you might have seen failures as well. So markets and academicians and researchers pushed a lot to go for MSC walls. Now I'm surprised, like one of my clients said, no, I don't want to go with the MSC wall. It is not because of the performance of the MSC wall, it is all because of the workmanship, poor workmanship, and maintaining the quality and control test. It is not the failure of MSC, it is the failure of the people. And these are the geocells, and this is used to stabilize the grounds, slopes, pavements, and it's a really very fantastic because of this 3D configuration. And seismic analysis, you might have seen the revised code and the news on the IS code. I think they withdraw recently. I just got the information. So seismic importance is increased. Maybe they are coming up with the few changes, but it is evident that each and every structure has to be designed for, because it is all about like not only about the money, but it is about the people. And this is a typical bore log, how it looks like. So this is the bore log and these are the samples, and they will number it and label it. So where it is conducted, when it is conducted, even they will write who is conducted as well, and the project. And these are the few samples in India. And this is the SPT sampler. So you see the difference. Though IS says that one dimension, but outside it is a completely different. And software tools, so there are plenty of softwares, and it is like I'm really happy to see that like VNRVJIET is conducting one full day session on the Slope W Geo Studio. So that is important. So very rarely people will get an opportunity to get a like hands-on experience in the UG itself. Majority of the people maybe they will experience only in the post-graduation. So we have plenty of softwares for different purposes. Sometimes maybe the same software can do the purpose, but they have a different codes, they have different practices, right? So different countries will adopt different softwares. Otherwise it is the same, slope stability, CKG is same, but they are used to it. And so one should know about like what kind of softwares in the market so that you will understand before. And case study one, I would like to share maybe a few minutes about case study which is in India only. So this is about like one construction is industry building in 2018-19. So this is the area where I will focus. This is the administration building and factory goods building. So this is the bore log. So you might have already heard, right, about SPT, what is the number, what is the importance. So SPT N value is low means is it strong or is it big? Any idea? As a civil engineer, third year, fourth year people can sense it and understand. If number is high, that means it is all about like resistance from the ground. So if it is more resistance, then your number will be high. So here you can see the numbers is like very high, more than 20, 25 happily go with the shallow foundation. So in this site, in this project, even the superstructure loads are very nominal. It's an admin building, hardly 10 kPa or maybe 15 kPa of live load. But surprisingly, it failed before inauguration. So then it is like forensic study, I would say, because it's after failed only like they asked us to find the root cause. Then what is the remedial measure? So I thought of sharing this with you. So the fine content, you might have studied like silt and clay. It's a combined lead. 35% liquid limit, 20 to 29, plasticity index, free soil index, Hyderabad limits. So if you look at the failure, so this is the grade slab, maybe like this. If it is resting on ground, we call it as a grade slab. If it is like other way around, if it is like inverted slab, if it is supported on the beams and load is distributed on the ground. So here the scenario is it is directly resting on the ground. Is this fine? Okay, I can continue. The problem is, you can see maybe here, there is a clear gap between the grade slab, it is a reinforced concrete, to the ground. So generally, you know, right, ground is going to settle on its own, never seen probably, but in the construction stage, so if you apply load, then obviously either it has to resist or it has to go undergo some volume change. In this case, there is no contact at all, but the soil is sinking on its own. So it was like a surprise for me and even for surprise for the people also. So the major problem here identified, so here you can see the picture. There is a clear gap, 100 maybe 100 mm to 150 mm, 10-15 centimeters gap. So, so what like made me too interesting is because it is settling on its own. So one should understand not about the bore log and SPTN value, the importance of like excavation layer. Why it is important? Because the foundations laid at a deep depth of 4.5 meters. It's a, like quite enough, and the soil is standing on its own. So they left these portions. It's not a complete excavation, and they missed the water table, and they felt that this is a temporary because there are a lot of structures. It is an SEZ, so they haven't found water table for the entire more than 150 acres, not even a single project. So they felt that this is a partial water table, or because of the monsoons, whatever the reason, they just ignored this is not at all a water table. And this soil, so it is a like recommendation can be, so this wording is really important, can be reused as a backfill. They haven't firmly said this soil is useful, only they said can be, and there is always a disclaimer. So that's where I said like you need to understand the legality. So the disclaimer is there, so they are safe, whoever is recommended. Now who is like suffering? The client ultimately and the consultant. So water table is temporary. The major problem is because this soil cannot be reused as backfill, and the excavation layout. So this soil is free to change their value. Over it, it's a completely like the grade slab. So that's where the problem started. And the water table is not everywhere. The interesting part is maybe in the next slide. Yeah. So this is the backfill soil. It's almost 4.5 to 5 meters. On the other side, maybe 2 to 3 meters. And this is a very dense granular materials. So depth to hard stratum is varying across the site. And the construction sequence, so ponding effect. In one of the slide I said, right, temporary arrangements, enabling works. So majority of the times at site what we do, they don't care about the drainage at site. But the places where the backfill soil or ground soil is like silt plus clay, that's a really important. Maybe they will ignore about the clay content, but even if it is like 15 to 30%, one should has to address about avoiding this ponding effect. So this soil is started softening, and this side is a pavement road. It is upgrade. There is no even subgrade material, but it is the performance is really fantastic. And the major client worry is about other buildings. These kind of buildings are more than 20, and it is about to inaugurate. And you know what is the budget allocated for civil? 500 crores. Then we immediately went ahead, like what is the pros and cons, how we can work it out, because the remediation measures are important. There are different measures. I mean, I'm not going in depth because it's all civil engineers. So here the problem maybe like you will understand what is the importance of like the consequences and the methods applicability. All methods are suitable, but you can't consider the cheapest method here because there are some restrictions as well about the height, accessibility, equipment. There are plenty of reasons. So these are the pros and cons. And this is the site, how it looks like. They entirely removed this kind of grade slab, and this is the status. So we recommended like the grout columns because of constraints like accessibility issues. If at all you ask me before the construction, it would have been costed you only 30 lakhs for this foundation. But we spent, like the client spent around 5 crores. So imagine where is 30 lakhs, where is 5 crores? And they haven't get even from the insurance as well. Because this already is settling, sinking, and they are about to open this office. They forgotten to approach to the insurance team. By the time they approached, so they shouldn't dismantle. They dismantled and they said no, we can't see because there is no evidences. You have photos, maybe why should we believe as a legal team? So insurance declined 5 crores from the pocket. And this is after the performance, this slide. So from here to here. So this picture I took after 2 years. So I always like emphasize like the Jimeski chart. So the ability, how you can influence. So these are the project stages from concept to demolition. We need to think about not only about the construction as a civil engineer. So you need to think about operations because that is the purpose we are building, right? And the demolition stage as well and reuse. So this is the influence. How can you influence? If you have like good time and it's well thought of it, then the cost to correct is very low at this stage, but it will increase. And the case study too, so maybe after this session you go back and see this MG Mangalore International Airport. So this is the tabletop airport. If you go back to the news, maybe 12 years back, like there was a airport crash, so almost only one person survived. Yeah. So this is about the Mangalore airport. And what is the problem here? It is about like the navigational aids. So these are the 2026 images, and these towers are the second in Asia. Such a large towers meant only for lighting, nothing. It's a navigational aid. The problem is about the terrain. You might have seen, right? So many slope stability failures. So now I would like to hand over to Prashanti to continue.
A very good morning to all of you students. And first of all, it's a really great honor to be present at my alma mater and share all my experiences as a professional geotechnical engineer all these years. And thank you, Suresh sir, for pushing me to present here. And thank you so much for all the professors, organizers here for giving a heart. And it feels so nostalgic to come back to my college and celebrate my experiences here. Thank you all so much. And what I thought I will present here is okay. What I thought I will share with all of you is like what I do on a daily basis. What sort of works as a geotechnical engineer that I do at my office. So I picked 2 to 3 projects to explain my experiences and my role as a geotechnical engineer there and how it has an influence on the end product. Yeah. So before I go and share about my project details, so I would like to let you know and I would like all of you to be accustomed to some of the terms that we regularly use in the industry. So the roles and responsibilities of any engineer, not only geotechnical engineer for that matter, be the structural engineer or the transportation engineer, whatever the role that you choose, and your responsibilities and roles, they vary depending on 2 major aspects here. So one is the project phases and another is the stakeholders. So what are these? So the project phases in brief are like you might have been hearing some of these words already. The tender design, concept and preliminary design, detailed design and construction support. So the tender design by name suggests the process that we do before the contract gets awarded to any contractor for the construction. The concept and preliminary design is the phase where we put together some of the pieces in the project and get some preliminary approvals from the clients. And detailed design is the phase where we give the details to every block in the particular project and get the final approval. And construction support is when finally the project is under construction and the sort of support that we as engineers provide sitting at our desk to the contractor. Stakeholders. So this name might be new for you, but what are stakeholders in a particular project? So I listed the two major stakeholders in any project, which are client and contractor. So who is client? So client is none other than the owner of the project. So who wants to build something is the client. And who is contractor? The one who builds the project is the contractor. So we have different roles depending on the stakeholder that we support and depending on the role that he gives us. Whether he needs a design support, we have a different role to play. Whether he needs a reviewer proof consultant, we have a different role to play. And when it comes to contractor, if he wants us to design, we have a different role to play. So this is how our day starts. So we decide to whom we are working, at what phase our project is, and what do we need to do. So to give you a glimpse of the day-to-day jobs, I've picked 3 different projects in my career, and I'm not revealing the project names due to the confidentiality. So I would like the session to be a bit interactive. So what I will do is that I'll give you the problem statement of the project in a very simple words. Now that you have got a little bit more understanding of geotechnical engineering from all the speakers, I want you to guess what could have been my role or what could have been my work then. Okay? So this particular project was an industrial building, and it has so many other buildings in that site. So the other buildings include, say, administrative building, fermentation unit, lactate synthesis. Like the names were different, just that every building has its own purpose to serve. And there are some tanks which are very sensitive to settlements because these tanks store the chemicals which are harmful, and we cannot let the tanks to settle more than the stringent limits that are given by structural engineers. So I'll wait for a couple of moments, and I want some of you to guess. And we have the investigation data available with us before we started working for the project. So any couple of guesses will be interactive. What could have been my role was? Oh, okay, fine, I will go. Now I was at that place once. I know that's why I'm trying to make it more interactive. So being an alma mater, I know that 3rd and 4th year students, how do we do? So try to be interactive, and for the next project, be attentive and learn, be attentive and understand the problem statement, and I want you guys to answer one question at least, okay? So here I'll explain you what we have done. So in this particular project, we were supporting the client as a designer engineers, okay? We were providing the design to client so that the client himself was about to hire a contractor to get the construction done. So we had the investigation data available with us. The first step that as a geotechnical engineer we do is that we take the investigation report. So what is investigation report? It has all the data of soil, at least the boreholes. What you can see in the little dots here, these are the borehole locations carried out within that site. Okay, so it has all the borehole log locations, and they have collected so many samples, and they have conducted some tests. So the first step that we do is that check and review if the samples are fine, the borehole log locations are fine. Do you want the client to conduct more tests? If so, then go back to client and tell him that no, we want more tests done at this site. That was the first step. And meanwhile, he does the additional test. We understand the ground and geology of that particular site by just joining the dots, a simple geology. Like we take all the boreholes, join all of them, and understand what is the extent of clay, what is the extent of sand, and where does the rock strata starts. So we get the basic understanding of the site. What is the type of soil? How does it behave? How much strength it can have? Yeah, and since I have told you that these are the buildings, so the basic role of a geotechnical engineer in a building's construction is to provide the recommendations for foundations. Yeah, it can be either shallow foundations or deep foundations. Like sir explained, there are different types of foundations, right? So we initially provide the foundation dimensions to the structural engineer and the depth where the foundation has to be laid. Yeah, and because he will work an initial expected load from the structures and foundations, and we give them the initial recommendations for the foundations. And also, since some of the buildings are very sensitive to settlements, we have to be very careful in assessing the settlements, and we assess the settlement for every foundation that we propose, and we check if the settlements are within the allowable limits or not. So that is the final stage. And so this happens in back and forth. So it's not like geotechnical engineer and structural engineer works in different silos, different rooms. No, we always have to interact with them. We understand their expectations, we tell them that this is how much the soil can do. This is what we do. So this, and also since some of the foundations require the filling here, we were also checking the suitability of excavated materials in the site. Like Suresh had highlighted in one of his case study that not giving a appropriate recommendations for backfill is one of the main reasons for the fatality failure there. So here we had to keep in that mind and check, get the required tests done for the excavated material and see if that can be used as a backfill. So this was the simple role. So now we understood the flow of the work. So for the next project, I want you guys to answer at least one role that what we could have done there. Yeah. So these are the typical details that we have received at site. Like sir has shown in his slide the borehole log. So for every project, we will receive a number of such periods to our desk and we have to review what is happening with the ground. Are there any local spots where one particular borehole show very weak soil? Is it real or do you think we have to have additional tests done there? So we have to have all those judgments here. So this is one of the building's foundation layout here and so we had used the some of the available tools with us. So we didn't calculate the settlements manually because if you see every foundation is close to each other, we cannot work the foundations as an independent foundations here because one load on the one foundation can influence the other foundation. So for that reason, we have used a software called Settle 3D, which can give us the settlements even when the foundations are close and nearby. And these are some glimpses from the project site. So it was only investigation at that time. So this was the SPT test that was conducted. This was the footing load test that was conducted at that particular site. Yeah. Now I'll go to project. Like I said, again I'll give a simple brief about this project. I would like at least a couple of answers from the crowd. Okay, so this project is one of the major infrastructural projects in India and located in the financial capital of India. I hope some of you might have guessed this project. And this project was meant to ease the traffic flow along the coastal line. Yes, to ease the traffic flow means without the traffic signals. To have a traffic flow without traffic signals, one of the way is to have the interchanges. I hope you know about the interchanges. So these two are the major interchanges within that project. And these two interchanges were falling right above the sea. So, but these interchanges also need the foundations. The foundations of the interchange were to be constructed within the seabed. Yeah, and because of the constructability issues or the economical point, the client and the contractor have agreed to construct monopiles of 3.2 or 3.6 diameter monopiles. So this is one of a kind project in India and second of its kind in Asia. So 2 and 3 meters diameter and we know the dimension. 3 meter is like one floor height almost. So this much long pile foundation that too in sea environment. And so we have the geotechnical investigation data and here we were working for contractor this time and we were working as a proof consultant, not the designer. So we were checking someone else's design and make sure that their design is appropriate, in compliance with code and it meets all the requirements of the project. So guess what could have been my role this year? Great, that's correct. Another, any other guesses? Okay, thank you for being interactive. And here, again, the flow is same. First understand the ground, geology, what the ground is giving us, what is present at the ground, is it soil, rock, if it is rock, what kind of rock it is, what kind of soil it is, that goes in the first round. And the next round is propose the required depth of foundations. So since we were not the full designers, the depth of foundation was being recommended by another designer, but our role was to check if the depth was sufficient or not. So even if we have to check, we have to go through the entire process again. So we have to design if the foundation depth is correct or not. So for that matter, we had done an independent design and checked if the foundation depth is fine or not. And bridge the gap between geotechnical and structural engineers. So this is another thing I want to highlight that, like I said previously, we do not work in silos. Like the geotechnical, structural, or other disciplines, we do not work in silos. We go hand in hand in every task that we do. So here, because of the complexity of the structure, the structural engineers have chosen to analyze this problem using a Midas analysis. You might have heard this software name, I believe. So the Midas analysis they are doing. So if they want to do Midas analysis, obviously Midas cannot explicitly model the soil that a geotechnical engineer wants it to be. So we have to bridge that gap. So we have to communicate how our soil will behave to a structural engineer in a more meaningful way. So in that case, we have to give the soil as a springs to the structural engineer. So we provide them those springs and they consider those springs in their analysis and make sure that they have accounted the soil behavior in their analysis. That was an additional role here. So to provide the to provide the soil springs, we have yes, it is Mumbai Coastal Road. It is operational, so I think I can reveal. It is a Mumbai Coastal Road project. So, and we have used a software called L5. So every time we do not go by like we have to have the basic understanding of our geotechnical basics, but we do not stay with the formulas. We try to make use of the advanced tools available with us. If not, we request for the advanced tool which you think are useful for the project. So for this particular project, we have used a software called L5, so which can model a monopile when the load is applied and it can give us the spring values that we were looking for. So I included some of the technical details from the project. So this is one of the interchanges. It was Haji Ali interchange. All this red text indicates the boreholes that were done. And the investigation, I can say it was so massive that the boreholes were drilled in the sea environment also. So we were able to get a clear picture of the geology underneath the sea. And this was a typical, like I said, we joined the dots from every borehole and understand how a particular layer is varying along the alignment of any project. So here if you see, it is in seabed, it is a marine clay, it has basaltic rocks underneath. So this gives us an understanding like how deep our pile can go and where should we take the pile foundation to. And this is a typical detail from a particular part of the interchange. So this has the pile foundations and also the representation of the soil next to the pile foundations, and this will give us a better understanding of where our pile flow is resting. Is it resting in a good rock or is it resting in a weak soil? So this is how we present our final recommendation. And this is the outcome from the software that I was telling, L-Pile software, which gives us an understanding of how the pile will deform laterally, and this particular curves will let us extract the spring values that we have to provide to the structural engineers. Yeah. This was another role, and these are some glimpses at site. He was one of my colleagues who had a chance to visit site. So this particular, you can imagine the massiveness of the project here. This is a, I think, 2.5 meters pile liner, and where a human is easily able to walk, stand inside. And this is the reinforcement cage in the particular pile, so where one can easily walk from one direction to the other direction. So this here is the testing that was carried out at site. So how do we ensure whatever we are doing and sitting at desk is appropriate? We cannot, rely on our results on sitting at desk, and we cannot rely on that completely. So every code has certain guidelines that you should test these percentage of files, and you should apply this much of load, and we should show that whatever file length that we have recommended can take the required loads by the superstructure. So here this particular load is called bidirectional test. I'll keep it in a very simple way. You imagine this is a pile foundation. Here a particular device is placed towards the bottom of the pile, and the load is applied in such a way that this particular device pushes the pile both up and down, and somebody sitting at the ground can understand how much the pile is able to take the load. So this gives us a confidence to designer, to contractor, to client that our design is okay and it can go to the construction. This is another project. It is not located in India. It is located in the other part of the world, in Australia. Being in GDC, we also get the opportunities to work with different countries, not only Indian projects. So this gives us a larger exposure to various guidelines of the guidelines those countries follow. But I cannot reveal the project name. So this project is, the aim of this project is again to have a signal-free traffic movement. But here, there was no need to choose the interchanges, rather they have gone with the lower waterway. So wherever you think there will be a signal, the motorway in one direction is lower, so the people can go this direction, and people in the lower motorway can go in this direction. Nobody has to wait. This was the project statement. And here, as you can see, somebody has to go down the ground, they have to excavate, and somebody has to retain it. Somebody has to hold the ground. So that's where the retaining walls comes into picture. So the retaining walls can be so many types of retaining walls, but in this particular project, we had used the diaphragm walls and tile walls. And again, here we were working with a contractor as a designer. So we were designing, and the contractor was getting the approval, so it can be constructed. So now again, we have the investigation data, we have to have the retaining walls, and any cases that what could have been our role as a geotechnical engineer.